Welcome back. It's been a while since we've done a video. The majority of the next two chapters, in fact, the next two chapters is entirely revolved around triangles. Triangles are by far the number one shape in geometry. We'll discuss them in the next two chapters. We will discuss them next semester when we get into special rights and a little bit of trig. So triangles are something we need to make sure we're comfortable with. We know everything about a triangle. So today's going to be mainly labeling sides, angles, making sure we know what everything's called in these three-sided shapes, these triangles. So we're going to learn how to classify these triangles by angles and by sides, and then I'll also identify these parts. So look at this first triangle here on the right. Triangle ABC is written as triangle ABC, and that's how you're going to write it. Make that a little bit neater. And it has the following part. It has sides. Okay, so you have side AC, you have side BC, you have side AB. Sometimes you might also see directly across from a vertex. It might be a lowercase b or a lowercase b, lowercase c. You can also see that occasionally. But we'll refer to them as side AC, BC, AB for now unless we see those lowercase letters. The vertices, pretty simple. We have vertices A, B, and C. And we also have angles A, B, and C. So a lot of things that we've already seen before. The side opposite of angle A, you would either say, again, so straight across from angle A, the side opposite of angle A is either A, or you could say it's BC, either one, if it was labeled as A. The side, or the angle opposite of AB, so look where AB is at, and now the angle opposite, so directly across from it, if you could draw a line, you would draw a line from AB across to angle C. So again, just getting familiar with this, making sure we know what's what. Acute triangles, obtuse triangles, right triangles, and equal angular triangles. We want to be able to classify triangles by their angle measures. Things that you have probably seen before, and you probably saw in middle school. Acute triangle. Acute. Think what acute, or that word cute in that word, means. Cute means small. You usually think about something that's smaller when you say something's cute. So in an acute triangle, all angles are less than 90 degrees. Okay, they're smaller than 90. In an obtuse triangle, one angle, just one, is greater than 90 degrees. If you thought about it, you can't have more than one that's 90, because if you did, you'd have a shape like this, and there's no way you can make a triangle now. So you can only have one obtuse angle. In a right triangle, okay, we already know what a right angle means. We have one angle is a right angle. And equal angular, all angles are equal, and therefore 60 degrees. Remember, a triangle is 180 degrees. So if they're all equal, they have to be 60, 60, and 60. No other way it would be possible. Using that information, what you have there, I'd like you guys to try 1, 2, and 3. Decide if they're true or false. Maybe draw a picture to help you out. Okay, we talked about number 1. I mentioned it there. So just write true or false. Again, maybe draw a picture. We will discuss these tomorrow in class. We've talked about angles. Okay, we can also classify triangles by side lengths. We have scalene, isosceles, and equilateral. Okay, in a scalene triangle, all sides are different lengths. Okay, we have 6, 12, and 13, all different lengths. In an isosceles triangle, at least two sides of the triangle are equal. Okay, at least. So it could be 3. An isosceles is actually part of an equilateral triangle. Okay, so if we look at equilateral, all sides are equal. Now this is technically isosceles because at least two sides are equal. We have two sides that are 8. We have 3, but two sides that are equal. So then we can call it still isosceles. So just be aware of that particular case. Okay, so we have angles that we've talked about. We've had sides. We can kind of combine them for both. Again, I want you guys to work on these 3 examples. Again, draw pictures, Think about what might work, maybe make angle measures for this case, and see what you guys come up with. Are they true or false? Tell me why tomorrow. Okay, number 4. Given triangle STU. Okay, a lot of the times we're going to have to draw pictures. I'm going to give you directions, but then I'm going to ask you to draw a picture so you can see what this looks like. So we have a triangle STU. You don't have to draw a particular shape triangle. Just draw any old triangle. S is 2, 3. T is 4, 3. And U is 3, negative 2. Okay? So we have 3 vertices. We want to use the distance formula to help decide whether STU is scalene, meaning they have no sides that are equal. Isosceles, they have at least 2 sides that are equal, or equilateral, all 3 are the same. So what we're going to have to do is use that distance formula that hopefully you remembered, or you have it on your cheat sheet. We're going to have to use it 3 times. So let's go ahead and use it for ST first, and I'll help you guys with that one. And then I'm going to let you guys do the other 2. So make sure you're paying attention on this first setup. So ST, if we look at this, it would be 3 minus 3 squared plus, actually I did y's, it doesn't really matter, but I'll stay consistent with my formula. So I'll do x's first. 4 minus 2 squared, subtract your x's. Then in the same order, doesn't matter in this particular case, subtract your y's. So again, this is x1, y1, x2, y2, 4 minus 2 squared plus 3 minus 3 squared. This will be a pretty quick, easy one. 4 minus 2 is 2 squared plus, this works out nicely. 0 squared is going to be 0. So that's 2 squared is 4. So the square root of 4 is 2. That's our distance from S to T. I want you guys to do the next 2, so it doesn't matter what order you do it in, but do TU, and then I want you to do SU. I said SU, not FU. Okay, do the next 2 so that you guys can figure out the distance between the 2. Okay, and then we'll decide what the relationship or what kind of triangle we have here. Okay, another example here. Equilateral triangle PQR. Okay, so there's some keywords here. Look for those keywords. Equilateral. Triangle PQR has sides measuring 4x plus 2 and x squared minus 10. Find the numerical measure of side PR. So again, draw yourself a picture. Get comfortable drawing pictures. Doesn't have to be perfect. You guys know I'm terrible at drawing. We have sides measuring 4x plus 2 and x squared minus 10. Keep in mind it's an equilateral triangle, so who cares how we label this? They're all going to be the same. And if we just said that they're all the same, we know that these are all congruent sides. So we want to say that these are all equal to each other. So let's say x squared minus 10 equals 4x plus 2. You see an x squared, you see an x, it becomes a factoring problem. So you have x squared minus 4x minus 12 equals 0. So your box problem, 2 numbers that add up to negative 4, multiplied to give you negative 12. Those numbers would be negative 6, positive 2. So let's put this in our ZPP form. So we have x equals 6 is going to be one answer, x equals negative 2 is our other answer. Check both. We want to figure out what PR is. So let's see what happens if we plug in 6. So we'll do 6 times, we can do either one because remember they're the same. So let's do 6 squared is 36 minus 10 is, so we should get 26 again. So that one works. Let's see what happens when we use negative 2. So negative 2 squared, because again you want to make sure it's in parentheses, negative 2 squared is 4. Minus 10 would be negative 6. We cannot have a negative side length. Therefore, that doesn't work. So PR would be 26. Okay? Rewind, watch that one again if you need to. Okay, a couple more. Number 6, use the diagram below to answer the following questions. Okay, I'm again going to have you guys try these. Okay, making sure you identify, look for all the right triangles, look for all the isosceles triangles, look for all the equilateral triangles. Those little hash marks will help you out when you're trying to look at those. So try and find all those for tomorrow. write them down. And then number 7 we are going to do tomorrow. At the beginning of class, I'm going to have you guys try number 7 with somebody at your group. Alright, first short video. I will see you guys on Tuesday.